Hello, and welcome to the Central Tendency Lecture. So earlier this week, we covered measurement. So we talked about categorical and quantitative variables. We also talked about the different scales of measurement being nominal, ordinal, interval, and ratio, each of those distinct from one another. So today we're going to be discussing central tendency. So as the name suggests, it's where things tend to be in the center. I know that's a really basic ass explanation, but you're familiar with central tendency. I assure you that you are. So let's get started. So this is just central tendency is one score that represents kind of where the different points in the data set tend to flock. So it's kind of the tendency of scores near the center. Oh my God. There are three measures of central tendency, that is mean, median, and mode. Now these might sound familiar because I remember learning about these and however old we were when we learned about mean, median, and mode. But this gives us an idea of where the data tends to kind of centralize, congregate. So with that being said, we'll start with the mean or the average. So again, average is more of a colloquial term, but essentially it is the mean, but I use them interchangeably. And when we talk about Excel later, Excel will call finding the mean the average. So this is our first time we're really seeing any formulas in statistics. Get used to seeing a lot more, but you guys pretty much know how to calculate how to calculate mean. It's just adding up all the scores together and then dividing by the number of scores there were. These examples that I have here, these formulas that I have here, is just the same, saying that exact same thing, but just in proper equation form. So we have two different formulas for finding the population mean and finding the sample mean. They're pretty much exactly the same, but as we move forward in the class, and especially when we go into variability, we will see that there is a distinct difference between population and sample. So I have these two listed here, even though they're essentially saying the same thing. I'm just getting you guys used to the fact that we are going to deal with populations and samples differently when we use calculations of formulas. So with the population formula, it is mu equals the sum of x divided by the sample size, or the population size, excuse me, I just slipped. So a capital N is going to be the population size. Sigma, that little weird looking E, is just the sum of, that's what that essentially means. That is the sigma that represents sum. There's another sigma that we'll talk about later, but for now, that is the sum. So the sum of all the scores, that's what X represents. And then dividing by the population size. And for population, mu is actually representative of mean. So you'll see here, if you don't know how to pronounce mu, it's spelled M-U, but it's not mu, it's mu. So if you're familiar with Pokemon, that was my childhood, that'll help. If not, that Pokemon is named Mew. But anyway, the sample is pretty much the exact same thing, except again, the formula has different notations. So instead of mu being representative of the mean, like it is for population, it is now a capital M, or you might see X bar, X with a line across, with a horizontal line across it. Either way, it represents the sample mean, and that is equal to, again, the sum of all the data points divided by, now we're dealing with the sample size, so it's a lowercase n. Again, these are all things that you guys are probably familiar with. We've calculated average before, just kind of in passing, or just sometime across the course of our, academic careers, we likely have calculated the average. So the median is the second measure of central tendency, and that is the middle. So to find that, you take the total number of individuals or data points, what have you, that lowercase n, add 1 to it, and divide it by 2. So for example, in this sample we have here, we have 2, 3, 6, 8, 10, and 25. There are 6 data points there. So 6 plus 1 divided by 2 is 3.5. So that is telling us the position of where the median is. That's not saying that the median is 3.5. It's saying that the median is located between the 3rd and 4th position. So if we look at the data set, since we've lined it up chronologically, meaning from smallest to largest, we'll go between the two numbers of 6 and 8, because those are the 3rd and 4th numbers in the data set respectively, and find the average of the two. So 6 plus 8 is 14, divide by 2. Our median for this sample is 7. So fairly simple. Median is, however, one distinct fact about median is that it is not affected by outliers. Outliers are numbers or scores in a data set that are much larger or much smaller than the rest of the data set. So for example, before we had the set that we used to calculate median previously was 2, 5, 6, 8, 10, 25. We have a median of 7 and a mean of 9.3. I calculated the mean off screen. You know, it's like in friggin' cooking shows where it's like, oh, here's how you make it. Now we have this already prepared. Well, I have this median already prepared for you, or mean and, well, median too. But anyway, so we have 2, 6, 8, 10, and 125 for the second data set. Median doesn't change. It's still 7 because we're still looking at that the number that's between the 3rd and 4th number in the data set. Those two numbers are still 6 and 8 regardless of the outlier. However, the mean is always going to be affected by outliers. So take note that before the mean was 9.3 when we had a more, a number closer to the rest of them with 25. Whereas when we pop on a 1 to it, when we pop on another 100 and say, oh, this is 125, suddenly our mean shoots up. So now we have 26 as the mean for the second data set. So that's saying that, okay, mean is affected by those super big or super large or super small numbers in your data set. Median is not. Median is just looking for the middle, and it doesn't matter how far the numbers outside the middle stray from it. We're just looking for the middle. Mode is representative of just the score or response or what have you that occurs the most often in a data set. So these can be used with both quantitative variables, so numbers that, variables that are measured through numbers and we find averages for. And it can also be used as a measure of central tendency for categorical data. Granted, it is the only measure of central tendency for categorical data. So we have, for quantitative variables, we can say, oh, 1, 2, 2, 2, 3, 5. The mode for that would be 2 because 2 appears the most frequently. But when we're looking at, let's say, a categorical variable of here we have colors, green, blue, blue, orange, red, 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 purple, the mode for that would be red because red appears most often. So those are the 3 measures of central tendency. Now, in terms of when to use them, we use mean very frequently in statistics, and it's used when our data distribution is roughly normal. We'll get more into exactly what a normal distribution is later on in the semester in a couple weeks, but for right now, we use mean a lot for statistics, especially in this class. So a normal distribution is that typical bell curve, like I can't really make it with my arms, like, but the bell curve where it's just like small on the sides, and then it kind of, the bell of it is just where the most scores tend to lie. So that typical bell curve is what we use when we're calculating central tendency for mean, or we use mean when we're trying to calculate the central tendency for those normal distributions, or the bell curve, if you will. For median, we use median when it comes to having skewed distributions. So oftentimes When we have skewed distributions, that's going to be when we are dealing things that with, wow, okay. That's when we're dealing with things that have either a lot. So instead of having that normal bell curve of it bumps in the middle, maybe it's like, woo, or woo, like it has a big blip and then it kind of flattens out for the rest, or it's flat, 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 and then it has a big blip. So when we have a skewed distribution like that, when that hump of the graph or of the curve is not in the center as it is for a normal distribution, we have a skewed distribution when it's way off to one side or the other. So when we have that, we would use a median to calculate the central tendency, because as we said, mean is greatly affected by outliers. Well, when we have a bunch of data in one half of the frickin', data points where they're all piled on this side or they're all piled on that side, our mean, if we use mean to measure central tendency, that is going to greatly be influenced by, oh, these super large or super small numbers. So when we think of skewed distributions, you can think of populations of cities in California or in a state, let's say, populations of cities, might be not just California, or income. So median is a very common measure of median is a very common measure of central tendency when it comes to income, because there's a whole lot of people who are, maybe at or below the poverty line, or just not making buku bucks. But then you have those couple people that are making, like, I don't know, it's about like 1%, I'd say, give or take, that are making much more than the poverty level. So those numbers will be skewed. So instead of saying, oh, the average income for the United States or the average income for California or whatever, instead of saying average, which will be skewed by the numbers that have so much more in them, we're going to be saying, oh, the median income for California is $55,000 a year or something like that. Same thing for populations of cities. Let's take California. So you think of a city like LA or San Francisco. Those are really big cities. And I'm talking about the city proper. I'm not even talking about all of the little, extra cities. The name escapes me right now. But just the city itself, there's probably millions of people. I mean, I don't know the exact population of LA or San Francisco, but I'd wager a guess that it's no less than 1 million people, considering we have like 500,000 in Fresno. So with that being said, we have these massive cities, or these pretty big cities in California with San Francisco and LA. And then you have cities like Exeter or Porterville or, Centerville, where they're a lot smaller. So obviously we're going to have a lot more smaller little cities than we do large cities, because you go down 99 or you go down, any friggin' highway, and you're going to see that, oh, there's like a lot of tiny little towns as we go along here, or just, more moderately sized. So we have a skewed data distribution when it comes to populations of cities. We probably have more smaller cities than we do big ones here. However, we would still use a median to measure that because it's a skewed data distribution. So we find the middle population size of cities. And then finally, with mode, this can be used with any type of data. So like I said before, it can be used with quantitative data. It can be used with numbers. However, it's not really common to say, oh, we gave this survey to people, a happiness scale, and we averaged it to find everyone's like depression score for themselves. We gave them 10 questions and we averaged them to find their overall depression score. And, oh, the mode was 4.2. That was the average. That was the most. There was more people with 4.2. No, we don't really do that. We just say, oh, we're going to find the average of everyone's total depression scores. And that makes more sense. So if we do use mode when it comes to quantitative data, it's not really telling us much. If people use it, it's going to be usually accompanied by mean or median, which is a little more descriptive when it comes to a data distribution, depending on if it's normal or, skewed. So with that, When we use mode for a measure of central tendency, it's going to be used for categorical variables. Now, this might sound like, oh my God, like, when would we do that? Well, if I were to ask, I've used this example before, but if I were to ask everyone in the class, what is your major? People would say psychology, biology, business, chemistry, etc. Well, I'm going to guess that the mode for the class would be psychology, because there tends to be a lot of psych students in Psych 42. It's one of the prerequisites to get your degree, to get your bachelor's in psychology. But it's also part of biology, but we tend to have a lot more psych students. So I would say that the mode for our class in terms of major would be psychology. Or the mode for eye color, I'm going to take a wager, a guess, and say it's brown, considering that brown is the dominant eye color. So, I'm just kind of spitballing it here. God knows, I might be proven wrong. Maybe the mode eye color is purple for all I know, but that'd be kind of badass, but I doubt it. Anyway. So we have an activity that's going to be due this week. We're going to be completing an activity and we're going to have our meeting. So with that meeting, we're going to be working on said activity. So we're going to be using Excel. And I have some Excel tips for you guys that I've posted that's published to Canvas as we speak, or as I speak. I don't know what you're doing, but I have some just examples here or some instructions on how to use Excel to do the things that we're doing for the activity. I'm going to explain it here, but I also have written instructions in that Excel tips, which is in our module in, Canvas. But again, so to find the mean, when you ask Excel to make any sort of calculation, you have to type equals and then a function. So essentially a function is, I'm going to tell Excel to do this. So to find the mean, the function that you use to calculate that is average. So before you do anything, let's say, it's kind of hard to see here, but we want to find the average hours slept, let's say. We have 8.5, 8, 9, 5.5, la-di-da-di-da. To find the average number of hours slept by these 10 people, what we would do is find an empty cell or square and just start typing equals average. So the equal sign, AV. I usually just double click on average because it'll pop up once you start typing. I double click that and then it's good to go. Once you've done that, once you have equals average ready, then you can just select the column or row that you want to find the average for. So boom, I'm just going to select from 8.5 all the way down to 6, and then I just hit enter and I found my average. Median, almost the exact same thing, except instead of typing equals average, you're going to start typing equals median. So the equal sign, MED, you're still going to find an empty cell. You'll see here that I've kind of gone over this. So average hours slept, 7.15 was the average hours here. And then the median, we just start typing median, double click it, and then select these numbers here and then hit enter, or select the column in which you want to find the average or the median for. So if we wanted to find the median age, instead of selecting the numbers from this column, once we have that function ready to go, we would just select the numbers from this column. Again, that's to find the median of age. Simple. So sorting data in Excel is actually another really helpful, useful thing to do. If you want to sort by, if I'm going to ask you how many men and how many women are in your survey, or how many people, if I'm looking at the difference between online and face-to-face students, let's say, if I want to sort how many online students are there, or how many face-to-face students are there, or what's the average such and such for the face-to-face students, or what's the average such and such for male students. What I would do is I would sort it instead of doing it by hand and counting each one where they kind of go back and forth. You're going to get like a male, female, 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 maybe trans male, trans female, other female, Instead of having it all fragmented where they're all over the place, sorting data will have it sorted in the sense where all your males are together, all your females are together, all your trans males are together, your trans females are together, intersex, etc. So it's going to organize them all together based on what you're sorting it by. In that case, it was by gender, but you can sort it by age if you want to, where it is from the youngest, and as you scroll down to the bottom of your data set, it is sorted to the oldest. It just depends. So in order to do that, in order to sort our data, we have to select our data. So this is a relatively small and simple data set here. It's the same one I used for the average, and median, but it's just to kind of demonstrate the point. So before you start sorting, you have to select all of the data like I have here. That includes the headers. Those headers are the participant, sex, age, and hours slept. So that's what that means. Those are the headers, the titles of each variable of each column. But you're going to select all of that data, and then you're going to click on the toolbar up here where it says data, and then you're going to click this sort button here. And from there, this little box is going to come up. You'll want to make sure that this box is checked here. My data has headers, because then when you click on this drop down menu, it's going to have not like, oh, column A, B, C, or D. It's going to say, oh, age, sex, age, or wow, age again. Participant, sex, age, hours slept, instead of A, B, C, D, which I find a little more beneficial. If I'm trying to organize the participants by age, if I'm trying to sort my data by age, I don't want to go back and forth and see, oh, age is column C, so I want to select from the drop-down menu C. It's easier just go, oh, age, boom, done. Anywho, so once the data is selected, you've clicked on the data set's selected, you click on the data tab at the top, you click on the sort button. This is going to pop up, and then depending on what you want to sort by, that's the choice that you will select from the drop-down menu. Again, if I want to sort it by participant number, if I want to sort it by gender, if I want to sort it by age, or even hours slept, I am capable of doing that. So like I said, if you have if this wasn't helpful, or if you need more of a step-by-step guide, because I know I said, oh, click on the data tab and then click on sort. If you need an even more step-by-step than that, if you need to see each, step along the way, say step one more time, Angela, geez. Anyway, so if you've done that, if you need that additional assistance, I have also posted Excel instructions on Canvas, and this is kind of providing you that more in-depth in words, and it has pictures and screenshots, so you guys can use that to your advantage if that helps, and I hope it would. So we have an activity, so yeah, we're gonna do that probably the second day. Oh my god, I'm getting a lot of fucking notifications. Anyway, so we're going to do that the second day of lecture of the week, so either Wednesday or Thursday, what have you. I've posted an announcement on Canvas, so you see that. However, oh my god. Okay, so I'm getting a lot of notifications. I apologize. But so make sure that you complete the survey that goes with the in-class activity, and we'll be sure to get that cracking. So if you have any questions, don't hesitate to contact me, again, through Canvas or email, or you can stop by my office hours that are posted. Just let me know. So that was central tendency. Those are measures of central tendency. Again, mean, median, and mode. We've heard these words before. So I'll see you guys at the next meeting or during my office hours. Boom, bam, boom, whatever you want. And I hope you guys have a good rest of your day, and like and subscribe.